My name is Lawrence Vernazza. I am doing a report today on General Motors Adaptive Cruise Control. This is for my final presentation at Weber State, ATTC 4540. So adaptive cruise control is very different than what I'll call a traditional cruise control. So for decades, we've had traditional cruise control where we could set a speed, and that cruise module would do everything in its power to maintain that speed, whether it be up a hill, down a hill. It tried to maintain the speed. That was it. Based on vehicle speed input to the cruise module and the set speed of the driver of the vehicle, it was really very simple. The cruise control module tried to achieve whatever the target speed was, and that target speed is set by the driver of the vehicle. With adaptive cruise control, it works much like a traditional cruise control, except for some pretty big differences. And the main difference is adaptive cruise control can adapt, just what the name implies, for primarily traffic, and really for the real primary is the vehicle in front. And it makes adaptations with throttle, with brake, and with the goal of keeping a safe distance between the vehicle in front of what I'll call the ACC vehicle. So again, unlike traditional cruise control, ACC has the ability to detect the path of the vehicle in front and maintain a safe distance. So in this report, what I want to do today is I really want to focus on the hardware and the data communications of the ACC, not so much all of the fluff that you can read anywhere, but I really want to talk about what makes this thing work. This is definitely this device, the Cruise Control Vehicle Distance Sensor Module. It's a huge initialism, CCVDSM. I'm going to just call it the distance module today, but it is by far the heart of this system. I would say it's the most important piece of hardware on this entire adaptive cruise control system on this Cadillac Escalade. Again, this is just a GM, but I picked a Cadillac Escalade. This module calculates the follow speed of the vehicle in front to ensure a safe distance, like I mentioned before, and it adjusts speed. That's exactly what adaptive cruise does. Like I said earlier, it'll apply braking and throttle to maintain that safe distance. I'm gonna elaborate on that quite a bit in a little bit. There's the location of it. It's right in the front of the car. This is off of a Cadillac CT6. But again, just right in the front there, sits right behind the Cadillac emblem. Location number 3. So let me delve in a little bit to this cruise vehicle distance sensor module. So this sensor module, as I said, was the heart of the system. It contains radar, and that's what really makes the system tick. It contains radar and the computer. It's all in one unit. We looked at that picture right back here. That's it. That picture in the background is the distance module, and that's the part that sits up front. That radar uses I'll call the ACC vehicle. That's the vehicle we are driving that's equipped with ACC. It uses the ACC vehicle speed as well as the vehicle in front to calculate follow speed. So it can maintain that distance, whatever that distance may be. When the path is clear, it'll resume, the ACC will resume and increase speed to the original setting that the driver selected, whatever that target speed may be. There's also a gap switch. I had talked about this in a previous report. It's very simple. Up on the dash, on the instrument cluster, when the driver of the vehicle, he has 3 choices, he or she has 3 choices. They can go either near, middle, or far. And what that near, middle, or far is distance between the ACC vehicle and the vehicle in front that we're following. So here's a really close look. This is good. This is what I think most reports should be like. We need to understand beyond all of the fluff and all of the marketing stuff that you can read online. So the Vehicle distance module uses radar, like I said before, and it detects objects on the road, and it just continually scans the field of view. And that distance module, what it will do is it'll make a request for either throttle or brake to the powertrain control module or the ABS module, EBCM on a General Motors, electronic brake control module. And it does this via the General Motors local area network, or GM LAN, in an effort to control the vehicle accel and decel based on radar. So once again, to review, the distance module that has the radar built into it with the computer continually scans the road, and that computer in the distance module will communicate via the GM LAN to the PCM and ABS module as to whether or not we need to increase speed to maintain that distance with the follow vehicle, or brake to keep that distance. A really important part that I learned while doing this report: engaging and disengaging the cruise control is performed solely by the PCM. So the powertrain control module has it's the last link in this operation. It has the final say, is another way of putting that. PCM will control throttle and brake to achieve the desired set speed, which I said earlier. And then when an object is detected, the distance module just calculates the range and decides whether to send a request to brake or accelerate to the previous module. So to review this, at the top of this page, you'll notice its distance module can talk to either the EBCM and or PCM. A little bit closer look, a little more detail on this. So the distance module can make a request, or not can, it does make a request to the BCM, which we'll talk about in a little bit, to command brake lights. So if you think about it, while we're doing adaptive cruise, if we're driving down the road and adaptive cruise happens to hit the brakes for safety, we need to command the stop lamps on. So these engineers have thought of everything. So the BCM will command brake light activation during ATTC, automatic braking. Another layer of fascinating engineering. These people think of everything, the engineers. The EBCM can also predict brake temperature. So if you think about it, if this cruise module, this ACC is just hell bent on maintaining this distance, it may command a lot of braking. So what the EBCM does is it predicts brake temperatures due to automatic braking, and they don't want the brakes to overheat. So when the brakes are getting warm, or when that algorithm has predicted that the brakes are getting warm, ACC is temporarily shut down by the PCM until brakes reach normal operating temp. All right, so let's add a module here. You'll notice at the top, now it's distance module to EBCM like it was before, to the PCM, and now to the body control module. And the body control module is a big player in this system. It provides a gateway to the GM LAN circuit, bus circuit. Gateway is just a module that translates multiple communication protocols. So we're going to look at a wiring diagram in a slide or two here, but the cruise control switches that the driver actually selects up on the steering wheel, and the gap switch is which is what I talked about earlier. The gap switch was the near, middle, and far. Those switches are inputs to the BCM, not to the PCM and not to the distance module, but the BCM. So the distance module monitors the input state being sent by the BCM to the distance module via the GM LAN. And as I mentioned earlier, the BCM measures brake pedal position and travel. It also sends brake information to the PCM via the GM LAN. The PCM will disengage ACC when the brakes are applied, just like a normal, if you think about a traditional cruise system. I said normal, maybe traditional is a better word. When you think of a traditional cruise system, when you step on the brake, cruise is commanded off. This is no different. It's just now that BCM, body control module, senses brake pedal position and buses that information via the GM LAN to the PCM to disengage the system. Remember, the PCM has final say as to the system engaging or disengaging. The BCM can also serve as a gateway to the instrument panel cluster, the ATTC, to command on any necessary warning lights and messages. And I'll show you 2 messages in a few slides. So we're going to add one last module, actually next to last module, we're going to add another module, the transmission control module, or the TCM. So if you think about it, and the system's just fascinating to me what the engineers have thought of, when the TCM detects, transmission control module detects ACC automatic braking, the TCM will downshift the transmission, just like it. Think about it with engine braking. We want to slow that vehicle down so it's not just all on the brakes. Again, it's amazing to me what the engineers think of. Every little inch, they've got to think of everything. And this is super impressive that they're going to actually command downshifting when the TCM is being told via the GM LAN that we are on the brakes, and the TCM is smart enough now with programming and software to command a downshift to help in braking. Pretty cool. I don't want to look at the diagram. It's not even that intimidating. I've heard a lot of talk about adaptive cruise and different things, but it's really not that intimidating. Right up here, if you can follow my mouse, right up here is the steering wheel control switch or switches, and there's 9 resistors up here. And this is not that much different than some of the resisted multiplex that's been used for decades. This is nothing new. So down here, there's a 5-volt bias circuit. That 5-volt bias circuit, it's a comparator circuit like we've had on, I don't know, engine coolant temp sensors for 30 years or 40 years. We have a 5-volt bias here with a resistor, little pull-up resistor. That 5-volt bias is sent out through the clock spring. Again, nothing new. And based upon what the customer selects, set, resume, whatever they happen to select on the steering wheel switches, as these switches close, there's a circuit that's completed back through the clock spring, and it either grounds through 5737 or 1884 to complete the circuit. Then right here, that's where the magic is. That's the comparator circuit. That's where the little voltmeter inside the module senses what that voltage is. And based upon whatever the driver selected here, the voltage will drop across these resistances, and a specific value will be right here at the comparator. At that point, the body control module knows what status or what state that driver of the vehicle has selected as far as cruise control. This is the distance sensing module. And you'll notice not a lot of drama here. It's got a hard ground on G102. It's got a B+ feed, a hot at all time feed up here. 3140 is a hot at all time feed. And then we have our ignition circuit, which is a ignition switch circuit to the module, and 4 GM LAN circuits. So if you think about it, it's not that overly complicated. We have 4 communication circuits delivering information out and into the distance sensing module. This is the module up front behind the Cadillac emblem. We have an ignition feed, a ground, and a hot at all time feed. The hot at all time feed is probably there for memory. And that's it. It's really not that complicated. I mentioned earlier that the Driver Information Center can display system warnings. The system warnings can be sent via the GM LAN again. And there's a couple of messages that can be requested. The most common is the one that you're looking at right up here on the screen. That's actually off of an instrument cluster, and it obviously says the radar sensor is dirty, or it's being blocked by debris or something. But the Driver Information Center can display different warnings, and again, that's probably the most common. The radar is either dirty or it's being blocked. And again, the distance module and the BCM can request messages to the instrument cluster via the GM LAN to illuminate specific warnings. Okay, last slide, and then we're all done. I know this was more than 5 minutes, but I know you mentioned a couple of times you want us to do our best work, and I could not possibly do this in 5 minutes. So I'm not worried about that. If my grade suffers, I'm okay with that. I just wanted to do it right. So this is my last slide of the day. You can also set diagnostic trouble codes. Pretty common code is a DTC C1002, and that's set by the distance module. And that code sets, that means maybe the car bottomed out or maybe hit something, or a body shop had hung a new front end and painted the new parts and put the vehicle back together up front. And all that means is it's an out of alignment condition, again, as a result of damage. That concludes my report today on General Motors Adaptive Cruise, and I want to thank you very much.